Alright everyone, so here we go. I may want to revisit, I'm not quite sure which one we're going to do today. We're going through all of these sliding window, longest substring, because we failed at this one, 2 pointers. I may want to revisit this one right here of the flower beds, but we'll see. I don't know if you want to jump over to here. I'll put this link here. Throw that out. Put that. I don't know. No, we could do an easy one. Well, I don't know. All these that I've had that were easy, and I was surprised there were prefix sum. I don't know. Let's see what that one is. Hash map. Unique number of occurrences. Unique number of occurrences. Let's start there. See what we have. All right. Given an array, I don't have this open yet. Gotten into a pretty good routine of flipping back and forth, because I go over and film on maybe this weekend. Well, I don't know. Everything may get turned upside down, topsy-turvy in the next week or so. All right. Given an array of integers, return true if the number of occurrences of each value in the array is unique, or false otherwise. All right. What did this categorize this as? A hash map. Yep. That's the way I was going to attack this. Because a hash map is fast. It is very, very fast. So a hash map, what's a hash map? Hash map is a set or a dictionary. I don't think there's a third one. So we'll copy all this over, and then we'll look at our examples. All right. So an array. 1, 2, 2, 1. So we're not going to be. There it is. All right, let's copy everything over so we can experiment and not have to run this so much. And yeah, I thought we sped that up pretty good yesterday, but it's still going. Nope, really, really, really slow. And move this over. And also, never hurts to clarify exactly what in the world we're doing. No. Clean this up, group this up a little bit better. All right, so this returns true. Wait a minute. Given an array of integers, return true if the number of occurrences of each value in the array is unique, or false otherwise. Well, how is this true? Because there's if a number occurs of each. Okay, let's look at this explanation. Value 1 occurs 3 times. Value 2. Oh. Oh. I completely misunderstood. So let's start back over. Peaky, how are you? All right, given an occurs a value of times. So, all right, let's go back through this. So, not the numbers themselves, the occurrences. So, holy moly. All right. So, we need to iterate through this. Let's get Paint open. Check this out. This is going to be crazy. DAX, big meeting today regarding data. Awesome. If you need a data scientist, I know where to find a guy. But hope the meeting goes well today, Dax. Good luck. I'm sure you're very prepared and it'll go great. All right. So we're literally going to be iterating through this and creating then some sort of grouping. Counter problem? I think so. So it's basically occurrences here. So an example of the one that just happened is there's 1, 2, 3. These are unique. So if we were to get a list and we need to then count, and we're counting, and if this is false because the way the occurrences happen. It looks like a W. We just need a single U. Oh, that's funny. A single U. All right. That's funny to me. Probably not to anybody else. All right. So a dictionary, and then return the keys. Oh, yuck. Okay. And this is false because there's 1, 2, 1, 1, and 1, 2. So the results of this one, and let's just look at this one right here. That would be 1 and 1. So that's false. Now, this one over here, we have 1 10, 2 zeros. Wait a minute. That's 3 negatives. That's 3 negative 2. 3 negative 3s. Oh, 4 ones. There it is. All right. 4, 3, 2. Oops. 2, 1. All right. All right. First, we gotta go through and just count these things. So for I in array, then we need a dictionary. Something was settling in the kitchen. That was weird. If I in D I increment 1 else di equals 1. Venki, good day to you. Hope you're doing well. We need to get as much out of these live streams for the next few days because I don't know what's going to happen, but I think things are going to be changing. So we need to squeeze everything we can out of these. All right. So let's run this. Print D. Print D. All right, run. All right. So here we are. And then keys. Yuck. We're gonna have to go through this twice. So we need to get this set up. No, values. D dot values. There we are. So that's our. Forget the logic collection counter. You forgot the logic collection counter. Yeah, I want to do this the long way first. So if anybody's jumping on here, it's like you teach a kid how to do long division, then you show them a calculator. But no, you 100%. And then we have to then go through and then figure out if that is the only occurrence. So we got to do this twice. And then we can go back and do counter. All right. So then we got to hit D. Yuck, I'm already not liking this. For I don't like any of this at all. This is very loopy. I have a feeling people have already answered this with the counter. It's going to be slow but we're going to hit that. No, we still got to iterate through the hash map. All right. Unique. Let's just do DU. I'm not going to spell unique right each time. All right. So for J in D dot values. Yeah, there it is. Let's put this up here, make sure this is running right. No, I don't want that at the end. I want that right there. There. Perfect. Okay. There's nothing in dictionary. Where? Peaky, where? Because we filled up, not in you, but watch this. We're doing this the long way. I know this is probably driving Vinky bananas. So for J in values, then unique, if I in you. All right. So actually break print false else you J equals 1. You're changing if I in D, but dictionary is empty. Right. So we'll. So interesting. So all right, let's slow down. Let's go over this. Let's go over this for Peaky. All right. So I'm checking if I is in dictionary, then increment by 1. So if you look right here, if we go through the first time, how about we print it here? Let's do this incrementally. Print D and print D. So we're going to print D a bunch of times. So I'll go over this and then we'll see the actual working process in this. I didn't want to have a not in here in case. I always try to think if somebody brand new is coming in. So if I is already present, we're going to increment by 1. If it's not present, we're going to place it in there and set its value to 1. So now let's run this. So this is an empty dictionary. You're 100% correct. But this else clause catches if it's not present. So then it sets the value to 1. Then it looks at the value if it is present. So basically, well, here, let's just run it. So here it is. You're exactly right. Empty dictionary. Then our first value of 1 gets set to 1 because it is not present. So it checks here, is 1 present in the dictionary? No. So that it jumps down here to else, sets it to 1. Bingo. Then 2 is checked. Is 2 in the dictionary? Nope. Sets it to 1. Aha. So now here is our second 2. 2 is present. Increment by 1. Now we have 2. And as it goes through. So does that help with that explanation? Well, let me know if that helped, Peaky. All right. So now, That would do. So by default, keys in dictionaries are numbers. No. Okay. All right. Let's slow down. Keys, whatever you set the key to. So because these objects are integers, because I'm iterating through with I. All right. And then I'm placing I as my key. So whatever I want to place in here. So let's check this out. Why can't I do that? So now I'm going to set let's do this. So now inside the S dictionary, I have set age to 47. So a dictionary, a key just has to be, what are the rules? If I recall, the only rule for a key is it can't be hashable. So an integer and a string, an integer or a string. You cannot set a dictionary as a key. But you can place anything as a value. So this goes, I like to say, goes in, this is like an address. And then also the key to it, because it's like tells you where to go and what to look for and how to get to this. So don't overthink this. So if it's present, because D is this, so 1 in D, yes, because it's right here. So then I pull up D1, pull up this key, and then I get 3. All right. Okay. So now I don't like this order, because with this, I as a key. Yes, that is exactly what exactly the way to look at this, because I'm creating a counter. You're 100% correct. I'm using a dictionary to create a counter. All right. Did that dot go away? Yeah, the sun moved. All right. And let's go back here. Okay. So now, false. That's supposed to be true. Boy. D dot values. Maybe I didn't build this right. 1, 2, 3. J. That's right. It's supposed to be J. And run. Print true. I need to do something here to make this work, because right now, since this is not a, so why are you guys learning Python? Is that to the people in chat or to me? Because we're just boning up on basically interview questions right now. All right. We need to make a temporary variable. False. No, true. All right, and then print false. I was back to false. And then temp. Actually, I don't even need that. I could just have this here. All right, because I only want this to print true, temp true, and then if temp there we go. All right, the people in chat. Oh, okay. Well, they're probably just wanting to expand their knowledge. All right, let's run this. Temp is not defined. We just defined it right here. And that's why. Because it doesn't hit there. True temp false. There we are. Now, this is why, as you're seeing, this is why trues and falses. False. Because I want this to happen. So if this, all right, because I want this to only print, because I can't have a print at the end because it would contradict, I would have false because I'm not using return. So this is kind of a secondary, hell, it might even be a tertiary, a third. So, all right. False. If this hits here, this is not going to change. This is not going to hit here. So, aha. I got to think through these things all the time. And then false. There we go. Okay. Let's see. A man who tries and fails has lost a battle. However, a man who never tries has lost the war. That's a pretty good one. I like that. You're using flags. Are you referring to these truthy and falsy statements? So what I'm doing here is, so returns clean up a lot of problems. So when we move this over, now this is going to be so ridiculously slow. But what I was doing is, so if I came down here and just, I was needing to control true. Let's comment this out. So if I were to make this, so I would get, and then if I were to change this to, let's add another, let's get rid of one of these. Actually, let's do this one right here. Copy, paste. This will be false, but then right here in this structure, yeah, I heard if you assign a boolean to a variable, later change it, it's called a flag. I guess it probably is, I guess. So yeah, this is what I'm trying to avoid right here, is to have this. So inside a function, the return solves a lot of this flow, but when you're using just print statements and you're printing true and false, and you're not inside a function, it gets a little chaotic. So what I'm wanting to do right here is I'll comment this out and then uncomment these out. So then now I will only get a false. So let's kind of go through this. And it even took me a minute to, because I'm awful with trues and falses and opposites and positives and back and forth. All right. So when this hits here, I want to only print the false. So if it is not, it's automatically going to print true unless this is hit. So then this is a basically hard-coded true. So if this happens, which is true, so do this. But if I've printed this false, I don't want this to happen. So I've changed this to false, kills this, and just moves on. All right. And boom, false. So now let's see. Let's check this one. Everybody here knows that this is going to be very, very slow because we're literally going through a dictionary, or we're going through an array, then we're creating a dictionary, and then we're going to be going through that dictionary. Now we do need to tweak this just a little bit to get this to work in our example right here. Move this down here. Is that aligned? So we need to get rid of these two. Don't need that. Don't need this. Don't need this. And this can be return false. And then don't need this right here. We can just do return true. So let's talk about what all this is doing right here. So when you do a return, not only does it kill the for loop, but it kills the entire function. So everything, if this gets flagged, everything is ceased. So this is where this is where a return can solve, I already read that one. This is where a return can kind of solve a lot of your flow, where you don't have to think in advance and solve these things. So if this gets hit, I don't have to worry about this truce. But basically, if this is not initiated, it will just come all the way down here. And if it doesn't hit here, it's true. Okay. All right. Let's see if we pass any of these. Oh, that's not going to be a good sign. Did you see how slow that was? We're going to have to jump over and probably do collections. See, there's no way. There's no way. They're having such a hard time with their timing. Let's do this one. Let's run this. We may come back and see if we can speed this up, because I want to speed this one up a lot. If this is 0 milliseconds, we know we have a problem. All right, that makes sense. I want to see if we can get this over to here, because I think this algorithm can be improved upon drastically. So, all right, let's come back over here. Run this. There's no way that's 0 milliseconds. All right. So does everybody understand the solve for this? Okay. All right. That one was easy. I wish that the easy and the mediums were consistent, because that felt easier than normal. All right. Did that mark it? Hash map, unique occurrences. All right. Determine if two strings are close. Ooh, I don't know what that means. Let's look at this. All right. Oh, this looks like a humdinger. Okay, let's bring this over here. There's a lot. Okay, so whenever you're seeing this many explanations, this is going to be awful. Okay. Come up here. That. Paste and save. I haven't even named any of these. That's not good, because that means I'm gonna forget. 1, 2, 3. Word 1 and 2. Let's clean this up. All right, two strings are considered close if you can attain one from the other using the following operation. All right, operation 1, swap any two existing characters. For example, A, B, C, D, E, and we go A, E, C, D, B. Okay, transform every occurrence of one existing character into another existing character and do that with the other character. All right, thought I heard something and don't know. All right, let's see. Swap, transform every occurrence. Operation 2, transform every occurrence of one existing character into another existing character and do the same with the other character. All right, A, B, B, C, B, A, A. All the A's turn into B's and all the B's turn into A's. Okay, what? Oh, now I see it. Okay. You can use the operation of either string as many times as necessary. Oh, hang on a second. I may need to go feed the dogs. Hey, baby, you ready for me to feed them?
Just put them outside, but yeah.
Okay. How you feeling? All right, everyone. Sorry, I'm feeding the dogs. I'll be right back. Are you guys ready? All right. Sorry, everyone. I am back. There we go. So, I don't even know if I can figure this one out. Anybody have any ideas how in the world we need to do this? Okay. Swap any two characters. Okay, so operation 1. So we have a choice of swapping two characters. But what is this considered? Let's go back. Given. All right. I think he's sending something. Okay, right. Occurrence. It's more redundant. Awesome. Let's see. Ooh, I like that. Okay. I like that a lot. So if you're not on Discord, you're missing out on all this cool stuff that Venki sends and speeds up and cleans up my algorithms. All right. Okay. So this is true. All right. So is this true? Okay. Can two strings are considered close if you can attain one from another using All right, let's look at this example. All right, so this is true. So we have ABC and BCA. So we flip-flop those. Okay. And the different count. Let's look at 3 because I'm not getting the explanation. The explanation is horrible. All right, let's go back. Let me see. Let me make sure I can see chat. All right. Word 1, CABBB. BBB. That was all an A and ABBCCC. Operation 1, where we're just swapping letters for letters. So there's how many choices of operations? There's 2 different choices of operations. All right, Peaky sent something. Okay. 2 different choices of operations. Transform every occurrence of one existing character with another existing character. Well, that's the same as this. Swap all the A's for all the B's. You can use the operations on either string as many times as necessary. Okay. And the first operation is swap any 2 characters. And then the other operation. So we have two different choices of options. All right, that sounds awful. So that means we have 2 checks automatically. So we need to go through this thing. We need to go through the strings twice. So that's going to be slow in and of itself, unless we can combine the swap all the A's for B's. So let's go back here. So we have ABC and BCA. But why is that true? Okay, let's look at operation 1. ABC and then I'm not seeing this at all. BCA. So we're swapping A and so you can do one. This is insane. So then you can do operation 1 and then operation 2, and then if you get the same string, you're okay. Because here we are. So we took A ABC and we swapped B and C. All right. So now it's ACB. And then then we do operation 1 again. And then we flip-flop. Well, I mean, you could almost get anything and could just continue to swap them. So then we took A and B and we flip-flop those. This one is nuts. I don't even know if I can begin to rationalize this one. Okay, so all right, now I'm getting okay. Let's put this in Paint. Let's get a new one. Here we are. Let's make this a little bit bigger. Let's go 40. Yeah, let's get rid of this. All right, change my mind. Let's go 48. Let's get crazy. There we go. Can I not grab it? Ah, there we go. All right, let's put this in the middle. See how big 72 is. Is that really 72? All right. It says it is. So we're taking, see if I can slice these out. Let's check this out. All right, first got to count the characters and how many times then appear. Again, I am defaulting the count. Oh, you're talking about, yes. So I now think, got a little too much white space. So these are exactly the same. Nope, cut too much off. There we are. So we have the exact same. Let's see if I can put this back. Yep. So we got the exact same, and we just swapped one character. But then look at this. This one drives me bananas. So basically, we could just continue to swap characters until we get what we want. But then the other one is, we may pass on this one and try to optimize the one we did a few days ago. And they call this, what they call this one? Let's see. Can't even find this. They called this determine if two strings are close. Maybe sorted. Sorted on the array or sorted on this one? Because this is cuckoo bananas. This is kind of crazy. It's a 54% submission. I mean, let's go back here. What, canned flowers? Let's go back. This is 28, and this is an easy one. Accepted. Haven't even gotten to 1 million and have 3 million submissions. Now, I've also wondered on this math here if this is every submission submitted, because that would make sense, because we were really, really close, and we just kept coming, because we did this one and we thought we were fancy. Then we found about the bookends, so I think we had to submit this. I think the order in which I did this is I did this, then I did these two, so there were 3. Then I can't remember what happened next. If there were no changes, so then I had to put it in an else. So if there were no changes, just return true because it was able to handle it. And then if, wait a minute, return. That's redundant. No, it's not. That's what I need. Hang on a second. But I want to go back and see if we can optimize this a little bit. Because I don't even know if I'm going to be able to solve this last one. Because this last one is crazy. All right, we've only been on an hour. Actually, we've only been on 50 minutes. All right. I don't feel that hot today, so I don't know how long we'll be on. But we're at least going to see if we can optimize this one a little bit. Let's go here. So we need to redefine. Let's get rid of this thing because I'm not going to be able to do this one, and it's going to make. I don't need to have one that I can't do today. I don't need that today. Let's see. Flower beds. Okay, so the flower beds. So let's go back. Not that. Flower beds. So check this out. I bet we can design this and make this go faster because we're going to do this with a while loop. And I'll show you why. Because we're going to be jumping around quite a bit. And then if we solve this one, we may do this asteroid problem. This is a stack. So let's go back here. All right. I learned an empty string dictionary int 0. How you feeling? Okay. I learned that empty string dict int 0 list are so important in Python. All right, why are they so important? I'm curious. I guess. I mean, they all have their purpose. I mean, that statement is interesting to me because I guess I'd like to know the rationale. I mean, you're setting a starting point. You're setting because, well, now actually we had one yesterday. Don't get hung up on setting an int to 0 because to count something. Okay. You remember how we had that one problem and we got it, count anything. Now, we got into an issue where we needed to bring in negative infinity because we were looking for the max and I set a default to 0. Well, I was getting a wrong answer because the correct answer was the average. And we were finding the max average, the highest average of numbers, which I can't even remember. Oh, is this right here? And this is still too slow, which I cannot figure out. And this is an easy one. This is the only thing that's frustrating me about Leetcode. Is the inconsistency. I love their edge cases, but their inconsistency of difficulty because this times out right here. But when we were looking for this average, which I made all sorts of mistakes, I needed to optimize this. But I think, we may go and do that because I do have a solve to optimize this where we're going to move the window over. And instead of taking the sum the entire time, I'm going to channel Vinkey. And we're going to move over. So we're going to sum one time. Then we're going to delete the last one and add the next one. So we won't actually have to sum an array of 32,000 every single time. Because this is why. So we can sum this once. But the size of the array. I mean, how big was the array? I mean, we can look at that in a minute. I mean, it's maybe 100,000. So as we're moving through this, that's why this is. But I want to show you right here, Peaky, setting this to negative infinity. It's basically any number that isn't going to be negative infinity, it will be larger than. So keep that in the back of your mind too. So we'll optimize this one, and then we'll come and fix this, because I'm pretty sure this is the solve. And I feel pretty confident, and I'm channeling Vinky to solve this, because that is exactly some sort of solve that we've done before, where we're just adding and subtracting instead of having to do an entire arithmetic. So the sum would be in the middle, and we would drop one integer and add another. So no need to resum and constantly do this heavy calculation, if that makes sense. So all right, let's go back and look at this situation. So we put these in OR because our operation was all the same, and we just moved over 1, and we subtracted 1. So we had 4 scenarios, and then a super sneaky outside scenario. So 1, 2, 3, 4. But they all did the same. Changed that I to 1 and decremented I from 1. All right, awesome. Okay. And then when we got to, and then there was no need to check the entire list, because once we got down to 0, we could stop. So that's why we broke out here. And then if we do get through the entire list, and Peaky, I want you to take a look here. So here's a Boolean comparison. So we didn't have to do if n equal to 0, return true, else return false. We just did it right there on that line. Is n equivalent to 0? True or false? Whatever the result is, we get it once we get to the end of this list. But now let's come up and kind of improve this algorithm a little bit. So let's think about this right here. So then we come here, and we're going to have a bunch of scenarios. All right. So basically, if we come right here and we have this situation, we can bookend and change this, correct? Well, if this happened, we can jump over 2. Because this is so silly. We're incrementing, and we're using a for loop, so we're automatically going to this next spot. Well, if it's this scenario, we know this is a 0, so we can just come and look right here. So we can actually cut our list. We can move over 2. So we can, if this happens, we can add 2 to I. Let's do that so we don't think it's a 1. Now, all right. So then if we get here, and then if this is a 1, if I equals 1, then we need to go through all of these scenarios, and we'll be able to speed this up, because I think at times we'll be able to jump possibly 3, and I want to come up with that scenario, because if we can get to jumping to 2 to 3, wow. So all right, so we're here and we jump to this space. In this scenario, we need to jump, let's go back. We need to jump here. All right. So if this is 1, is it just jumping 2 all the time? All right, so what happens if this was 2 pointers? Possibly, because I'm awful at 2 pointers, so it may be. But we need to be looking at a group. So I think this falls under a sliding window. Let's go back, because they do tell us. Yes, this is a sliding window. So we're looking at these right here in this in this group, because it has to be, it's either that or this. And then if it's at the end, we're looking at these two. So the window changes depending on where it is. But right now, if we speed this up and we jump 2, that can do it. Yeah. Because also what we're going to do is we're going to take I and we're going to look in front and behind it. And until we get down to until we get down to this scenario, and then it changes again. But right now, I want to because literally it'd be while we'll have to work on this one. But right now, I think it's just while I is less than in, then all these conditions add 2. Because if we come here and we change this, let's come up with a different scenario. New book or new pad. All right, not that. This. Let's do here. That's awful. Here. All right. So how many can we place in here? We can only place 1. I'm just glad it does. We're not asked where to place it, because I can place 1. Oh no, it's 2. Check this out. It's 2. I can place 1 here and 1 here, because this is the bookend. All right, so let's go back and check this out. So how would this be our algorithm? So I check here. So this is a 1. Here's where it would jump to. So if this is a 1 and our next one is a 0, jump 2. If this is a 1 and this is a 1, jump 3. There we go. That's the explanation that I was looking for. Because let's go over why we would want to jump 3. So I would be right here, and it needs to have a group. So if we made that 1, so I is here, we peek at our next one. If this is a 0, jump 2. If it's a 1, jump 3. And then every time, if it's not at the end and if it's not at the beginning, do we have 3? All right, does that make sense? In the middle, it needs to be 3. That is not middle. That is a gross. That is a horrible. We're gonna try middle again. All right, that's a better middle. If it's in the middle, it's 3 zeros. If it's a bookend, it needs 2. If it is a 1 and the next one is 1, it jumps 3. If it's a 1 and the next one is a 0, jump 2. Wrong answer for. Is that the one we're doing right now? Let's see. 147, 169. Which one is that for, Vinky? Or is that for the unique? Or are you back at what is this one? Maximum average. Oh, close strings. So far, 147 got correct. Okay. All right. Let's see. So you're knocking that one out? All right. That's very impressive because I don't even think my brain's not going to be able to handle that one today. All right, let's optimize this and see if we can get this faster than this bottom 18%. Oh, is the timer back? Let's see if this timer is back. No, still saying it's 0. I know we're not 0. I know we're not that fast. All right. Can do flowers. Okay, let's get this ugliness over here. Flowers, flowers, flowers. And we'll come back and work on this. That's our shortest word. I like that solution. I thought that was very elegant. Candies. Flowers. Here we go. Was this all the... That was all the... Cut, paste. All right, let's come comment this out. Oh, I did already. Oh yeah, because we didn't get very far with this. Let's see. We'll bring all this down here. I think that's why I killed that last mouse. Because I just roll your boat. All right, that's a little cheesy. Sorry. Had to do it. And after. One more time. Rollies. Copy and paste. Cut. I think right there is paste. Yeah, there we go. Okay. Move this up. So we need to control while I is less than. We do need to control how close we get to the end. So we are going to have a problem as we move to the end because we're going to be jumping. So we need to test and see where this is. Because if we get to the end, yep. Sorry. Nope, we're doing this over here. While I less than n. All right, let's see. This is thrown up so big time. Okay, let's go back because I'm stumped to why that's not working. While I less than L. While I less than L. I0. There we go. All right. So, of course, it was thrown up because I had not set I to any sort of value. And then I plus 1. If n equals 0, break. Okay. I increment by 1. All right. Let's start flattening this out. So if I is 0, if I is 0, we need to go, okay. Copy. Oh yeah, all the i's are going to be different. Doesn't matter, sorry. Cut I goes by 2. All right. So that's our first bookend. And then, so that was here, here. Change I, move over 2. All right. So now, what is our next one? If I is oh, that's so funny. Oh, good Lord. My daughter wants to put up Christmas stuff this weekend. And that's so funny. Okay, let's keep moving. So we're going to move this over 2. So we're going to have a couple more scenarios. So then if elif this change okay. Oops, that's not what I wanted. All right. So we're at the end. We did our bookend. Then we need to increment I by 1. No. I equals 0. No, that's not the end. If I is 0, that's not the... Whoa. What was that one? elif. So if we do, okay. So we could flatten these together, and by the number of groups of i's. All right. So because if this scenario is 2, this is also 2. Because if that gets changed, all right, here we go. So we can put this together. Or, that's a cut. Bingo. All right, let's go over that. Now, we are going to have an issue with the adding and subtracting, or the incrementing of I. And then I want to see how much we can speed this up. Because this scenario now also elif, we're going to have a problem with the end. And then if we change one, if we move over, so if I, here we are. if index I is, let's start over. Let's clear this. Let's come up with this algorithm. So array is this. 0, 0, 1, 1, 1, 0, 0. Okay, cool. Here we go. This is a perfect one. So I. So if this is here, it's going to change to 1 and jump to here. But now, if this is I and this is I, we need to jump. Crap. We need to jump, because if this is I and this is I, we need to jump 3. Does that make sense? Because we automatically know that we can't have this beside here. So it's pointless to check this. Does that make sense? It's pointless to even check if this is I and we take this peek. And if this and this, aha, there we go. So if this index and this index is both 1s, we jump 3. All right, check this out. Let's see. So now, all right, elif, I can't remember what this one does. So if I is 0 and flower bed, I need to look at something. Was I originally the range? What was the last? Okay. Got to tweak this. So this is this. So that, oops, that's wrong. So I copied this. So my bad. So this is still the first one. So now we need to do, if first one is, let's handle the one where if I and the next one is elif. What do I want to do? I and the next one. If I and the next one are 1s, so if flower bed elif flower bed I and I plus 1 equals 1, 1. We're not changing anything. Range in Python generates numbers or decides how many times to loop will run. All right. Don't overcomplicate that. Range creates a object of a group of numbers. So I'm going to wrap this in so you can see it. That's all range does. And we're applying it to a loop. So then I take, so if I needed to quickly create numbers from 1 to 100, this is what I would do. So I needed 1 to 100. And I didn't want to type them all out. I now have a list of numbers 1 to 100. So I know it decides and generates 2, but sometimes it's 100. Oh, it's 100% confusing. This is so weird. This is so I mean, you're reprogramming your brain, literally, ha ha ha, pun intended, to get your mind to think about this. So I plus 1 equals 1 and 1, then I increment by 3. All right. So then will that... I am very worried about the end. It needs to also be... Let's see... Let's comment this, because I also need, if okay. Is this the last? Yeah, this is the last one. This is the bookend at the end. My problem is I don't want to overjump, but I can't overjump. Because if that's here, that's here. And then I would come up here and check, we'd be done. All right. This is going to be, if I... And elif... Whoa. Oh, oops. Then flower bed I, there we go, and one, okay, got you. So range is an iterable. It does it creates an iterable it creates an iterable object. And the formula for a loop is for I in iterable. Bingo. Always loop through iterable. Sometimes code may not say it in another function. Yes, that is 100%. So when I do for I in range 5, I'm iterating through that iterable, and range created a range object of which it doesn't show us. Yes, and I'm trying to remember if it has actually a generator, because you don't see the entire object until it is. Well, now I am very intrigued. Well, now we're down this rabbit hole. Range objects that produces a sequence of integers starting with inclusive. Okay. Right. Well, we're already down this rabbit hole. Range. Is it the same? It feels very generatory. Because when you do, like I said, when you do range, you get this. And then for I in range 5. Because you're only going to call it, you're only going to hit that next object when you're hitting print. So it's next. Man, that looks I don't know. I haven't ever looked all the way into that. But yeah, when you start to get sometimes functions return objects, not values, and objects are actually hidden things. No, that's I don't want to go down there, but no. Objects are actually hidden things. No, an object isn't. I mean, X is an object. I mean, it's an integer object. So I wouldn't overclassify it that way. Just settle where we are with the range function creates a iterable, and stop there. All right. So now let's see where we are. So this is at the end, and I move over. Now what is this one doing? If I equals 0, oh, I need this too. Okay, why doesn't it like this? Flower bed I, unmatched. Print. Let's see. Print. Okay. I gotcha. All right, let's run this. Okay, no. Oops. So I'm not incrementing L properly because I was stuck in a loop. Oh, I got to the end. I increment 1. Okay. This is also why I don't like while loops. I can't ever handle all the incrementation. Okay, so I have I. I'm starting at 0. Let's see, where am I missing? I mean, sir, you said X is an object, which is obviously right. So that means every function returns an object. No, not every function. Every function can return an object. So yeah, it is whatever the function you define the function to be. So if a function can create an object, so we'll look at that in a minute. It is very tricky. You are 100% tricky, but let's not get. You can. That's what can be challenging about this is you can begin to drill down too many layers and really muddy the water. So let's go up a few layers and see if we can get this to work, and then we can go from there. But right now, right now I'm trying to figure out where in the world I'm causing a infinite loop here. Because I'm incrementing unless I'm not hitting. Oh, okay. Sorry. All right, sorry. Else else I plus 1. Let's see what in the world happens here. Yeah, that was it. So, problem is I had a scenario that didn't get caught. So let's go through here. All right. Okay, that's good. This should be false. Okay, that's good. 1, 2. This should be false. No. Sorry, this should be true. 1, 2. Then let's change this to 3. This should be false. Don't get hung. Then don't do it. Then don't get down functional programming, and then work on object-oriented programming. You don't have to. I mean, it's like I like climbing, but I sure can't climb Mount Everest. So don't climb Mount Everest. So, let's see what I've unleashed. Oh my goodness. Oh my God. There we got. It is never boring at my house. Okay, this may work. So all right, so let's go back here. So we're checking everything. So basically else just moves it over. Let's see. Here we are. This should be false. 2, this should be false. Then when I go to 1, this should be true. Okay, this actually may be. Like that. What are you talking about? Daughter stuff. It's never boring. Oh my goodness. X. I gotta start putting stuff on LinkedIn. It's the only way I'm gonna get the job that I want. Okay. Sir, I'm not climbing Mount Everest, but I know I have to do it as a good Python programmer. Well, yeah, but what my point is do something that stretches your goal. And these things come over time. So I know I equate jujitsu and programming. So last night we worked on finishing a type of a choke, and I didn't understand. I had done this thing for 15, 16 months, and I never understood what we were doing. I thought I did. I was moving my wrist in the exact same way, but the placement of the wrist changed everything. I was trying to pull it down instead of pulling it in. So I say all that to say this. Make sure you're doing something that you will get a little bit of improvement with, and the rest will come with time. If you're going to constantly go and try to do something that is absolutely unattainable at this moment, you possibly might understand it, but realistically you probably won't, and you'll become so frustrated you'll give up. So what my point is to do something just a little bit harder than you're able to do. Just a little bit, just a teeny tiny amount harder than your best right now. And then you improve that. And then what happens is you go, okay, well, I just did that. I can do this. And then and then you're doing this and you're swimming around and you're understanding something and you go, oh, wait a second. Now I get what that is. So you're immersing yourself in it while you're building confidence, and you're wanting to be. So when you build confidence, you want to be there. And if you have realistic expectations, you can create a false and inspiring self-confidence. So that's why I'm saying you're not going to turn around. You're not going to if object. Yeah, just improve. Go and do something that is just a little bit more challenging than you did yesterday, and then the next day, no worries. Then go and do something a little bit more challenging than the day before, and then what you'll do is you'll turn around and you're going to go like, oh wow, I sure have come a long way. And then by doing that, your comprehension and you reprogramming your brain of looking at these objects, no, pun intended, differently, then you have these aha moments. So don't rush the aha moment. You can't rush it. You can only just be consistently doing it over and over and over again. Like space-time. We knew there was gravity. We still really don't know what causes gravity. We just know large mass objects. There's a direct proportion between the size of your mass and your gravity. But then it was like, well, hey, okay, how is this gravity being transmitted? So then that's when the concept of space-time came to be. Somebody just didn't wake up one day. They just kept swimming and immersed themselves in this topic and constantly understanding more. Well, wait a minute. If this is happening here, then something else has to be happening here. What could it be? Oh, wow. And then you just have these moments and moments and moments. You cannot force these moments. Now, you can speed them up by doing it more and more and more. That's the only way that's the only way you can speed them up, is by spending more time doing it. Everyone thinks that there's a shortcut, and it's not. The only way you can shortcut it by the amount of days is the amount of hours you spend in it each day. Or how can you shortcut it by the amount of weeks? How many days did you spend on it? That's the only way that you can speed it up. All right, so now let's try this one, and then we'll place this in here because now we're jumping 2, we're jumping 3, we're jumping 1 and 1. So technically, we put 2 with that 2, and this, we have 1s and 1s here. So we could technically do this right here. Or this. Cut, paste. This is the only time you can put things together like this, is if they have the same output. But right now we have, so -1 and 2 plus 1. Oops. Don't need that. There we go. That's why I came here every day to see and spend some hard time with my brain, remind my brain, if it's not today, but one day you're gonna solve this problem. Good, and that's all you can do, and you can only control your effort. You can't control anything else. You can't. I gotcha. True, Venky. You can only that's one thing that us humans really struggle with. You can only control your effort. So everyone thinks they can control everything else, and they can't. I can control showing up every day. I can control getting up. I can control going to sleep. I can control eating. That's about all I can control. But the more that you're consistent and the more effort that you put in, you'll be shocked at the amount of results. So, all right, so we've cleaned this up a little bit. We have a scenario here where we're jumping 2 and we're decrementing by 1. We have a scenario here where we are jumping 3, not decrementing because we have 1s already. Then we have another scenario where we are subtracting 1 and we're decrementing by 1, incrementing by 1. And then if none of those scenarios are happening, which means we're just constantly looking at 1s, we increment by 1. So that was our last one because we accidentally fell into an infinite loop. And now let's check this. So we're on this last one right here. So we could technically have 2 here, not 3. So 1 should pass. True. Now we go 2. Pass. I want to see pass. And if I go to 3, I should fail. Because fail. Now I want to add. No, because we just tested this one right here, right? 3 should pass. True. All right. Awesome. So we've just, and we have our scenario at the end. We have our scenario with 1. Yeah. Let's try this. Oh, actually, no. Let's do one more. We haven't tested this one. One. True. Okay. And then 1, 0. True. Okay. We are ready. We are ready to go. Let's go here. Whoops. Paste. Tab over. Send rover right over. Let's see if this doesn't crash. And it crashed. Oh, we didn't create our I equals 0. I equals 0. Run again. I don't have a problem with the Christmas tree going up. I need your help. Okay. Yeah, apparently we're doing Christmas stuff already. Did this go through? All right. Didn't crash on that. I'm at 940 locally. This is even slower? How is this slower? We're skipping over. We're making huge leaps. Well, that's annoying. That is very frustrating. Well, now I want to see. All right, how long have we been on? Hour and 40 minutes. We're going to look at one of these solutions and see. Oh, solutions, not submissions. Beginner solution to the problem. That's Java. Let's see, Python 3 is a video. Simple solution, easy to understand. They go through. Oh, wait a second. I'm doing this all wrong. I need to pick a fast one. Later. Runtime. There we go. All right. Else. How is this even? This is no faster than ours. They do a range and they check every single scenario. I would argue ours is more elegant than this. Look at this. I know this is faster because we're not even hitting each element. We're not. So that is extremely annoying. But we're gonna wrap up today here, and we'll pick back up fixing this one tomorrow. All right. Okay. Thank you everyone for coming to join us today. Hope everyone is doing well. Because of more if else, I guess. No, so you don't get. No, I don't know if where my where I hit the communication of to the server. No, so you get charged time wise with how much time it takes you to get through the object. So linear time, you're touching. We're not touching each. The only thing that I can think of is we're peaking at this. That may be. Vinky may be able to speak to this more because we're looking at. I'm slicing every time, so that may be slowing it down. Let's look. Do they? But they're hitting len all the time. What is this? If num null equals 3, that's an interesting. So they're not even looking at the first object. All right. Maybe we'll look at that. So I'm running this code. Submit. I want to see how fast it is. Yeah, it was even slower than ours. So they, yeah, now I feel even better about that. Okay. No, think about iterating through all of the lists. So think about counting to 10 and 10,000 and then 10 million. But like we're going through right here, we're counting. So it's like, can I count to 10 million? Which one will go faster? If I count by threes or if I count by twos. The only thing that I can think of is this takes more time, and I'm unaware of that because I'm looking both directions, and there may be a cost associated with that I'm unaware of. But I was thinking that I would be making it up by incrementing, because right here we're automatically incrementing by 2. Because when we're here, we just automatically need to go over by wait a second. This needs to be 3 because 1, 2. So I'm looking over. Nope. Let's move this here. If I'm here, let's go back. So 0, 1, 1, 2, 3, then let's just see this. So if I change this to 1, then I go over 1, 2, but I can't have this here. So I need to go over 3. Yep, that needs to be down here. Let's try one more. Let's try one more. See if this speeds it up any. All right, so that algorithm's wrong, but that would be I know what it is. elif and n -1. Try that. Oh, I give up. Okay, I should have moved this here. All right, let me go back. Okay. All right, now I'm really going to go. But that should work. Okay. I know that's not that slow. All right, I'm going to wrap up today. Thank you, everyone, for being here. We've been on for almost 2 hours. So thank you, everyone, and I will see everyone tomorrow. Make sure you hit that subscribe button. Hit the Discord server so you're not getting any, you can get all the support you need. But thank you, everyone, for joining today, and I will see everyone tomorrow. Bye, everyone. Thank you.